Hi everyone, welcome to this new edition of PHP Sussex. Thank you all for coming. My name is Yannick, and if this is your first time at PHP Sussex, we are a Brighton-based user group dedicated to the PHP programming language and to web development in general. We gather roughly every other month, usually on the second Wednesday of the month. We have a great speaker for you tonight. David Liddament is the director of Lamp Bristol and also the co-organiser of PHP Southwest. And they also hold their meetups on the second Wednesday of the month, but exceptionally tonight, Dave is escaping his meetup duties to be with us, so we thank him very much for that. Tonight, Dave is going to talk us through the Test Suite Holy Trinity and how to get as close as possible to it. And we're actually doing some sort of exchange here because next month I will be in Bristol to speak at PHP Southwest. So yeah, please be exceptionally nice to Dave tonight. Before we get started though, Cameron is going to tell us a few words about Silicon Brighton and Runway East who kindly support this meetup tonight. And then I've got a few more things to tell you, but yeah, for now, over to you.
Thank you very much, Yannick. It's really weird speaking to a mic and it not amplifying anything. So yeah, it's good for their experience, but for you guys, it's pretty odd. But yeah, so my name's Cam. I work for Silicon Brighton. We're the hosts of Brighton and Hove's digital tech sector, which is made up of loads of different meetups that we support. A lot of these meetups we run in Runway East, which is a phenomenal venue, and we're very, very grateful for them to look after us and give us the venue free of charge, which is fantastic. So we're really appreciative of them. But yes, so in addition to Runway East, we also have lots of supporters that are all local businesses that support community, as well as getting a bit of publicity there for themselves. So it's definitely worth reaching out to any of these people if you think that perhaps you'd like to start a new career in one of their sectors. They value community and they're very upfront and brilliant to chat to and always wonderful to talk to with. We also are sponsored ourselves for everything that we do by a company called James Chase, Plus Accounting, More Law, Alirity. And also you can stay up to date with all of our activities on this link tree. We have a Slack channel, we've got a YouTube channel which we upload and live stream the events to. So the conversation doesn't have to end this evening, you can jump in, and the Slack channel is a fantastic access point for all of our meetup groups, and you can find us there as well. Jumping back to our flagship event, which is this giant banner here, is Evolve. It was a brilliant conference day last year that we hosted at the Brighton Dome, and this year we're doing it even bigger and better at the Brighton Centre. We're also partnering up with PHP, where there's a discount code. The tickets for this conference aren't your usual sort of price schemes. It's £40 for a standard ticket, and the PHP Sussex code will half that to £20, and if you're a student, it's £6. It also helps support PHP, so if you've enjoyed yourself tonight and you want to give back something back to the community, not only do you get a conference ticket, you also support pizza and drinks funds as well. It's set to be a great day, and yeah, please check out that code if you fancy coming along. And yeah, thanks, Yannick. Appreciate it. There you go.
Thank you, Cameron. Yeah. Yes, quick word about sponsors. We are looking for one or maybe two sponsors to help us with the cost of drinks and food for the rest of the year. So if you'd be interested in sponsoring us, or you think maybe your employer would be, please do let us know. Yeah, sponsoring PHP Sussex is basically, it's a good way to promote your brand, really, and to get the word out when you are hiring, for instance, or it's just a nice way to support the local community as well. So yeah, do think about it. Something else. Yes, we are currently running an online survey to try and understand a bit better what you expect from PHP Sussex, so we can hopefully steer it in the right direction. It's not a very long survey. Yeah, it shouldn't take more than 2 minutes of your time. It's completely anonymous as well. So yeah, please do take the time to fill it out. It's really important to us that we know what you think. And last thing from me, after the talk, we are going to head to Unbarred, which is a pub around the corner. So you obviously don't have to drink any alcohol if you don't want to. I mean, you don't even have to drink anything, really. It's just a nice way to wrap up the evening and to prolong the conversation. I think actually they've got some nice alcohol-free beers that you can try. You know, if you wanna try that. Anyway, I think that's it for me.
Is there anyone? So I might take a couple of pictures during the evening. Is there anyone who doesn't want to feature in any pictures? Let me know now. Okay, brilliant. Just check that first.
Nice one. Okay. But yeah, that's it from me. So Dave, you're up.
Oh, yeah.
So yeah, please welcome Dave Liddament for his talk, the Test Suite Holy Trinity.
Thank you very much. Is that playing? Oh, yeah. Is that going to hit my mouse back? I might need to find a responsible adult who can... Oh, yeah, there we go. Oh, there we go. Looks like the same. Thank you very much all for coming along. So we all know testing is good. We all know that if we do testing, we'll have confidence that our code will work. We'll have confidence that we can refactor safely, and we have confidence that when new features come along, we won't break any of the existing features. We know that. But often the reality can be just painful, really. Tests are running slow. You make seemingly inconsequential changes, and lots of tests fail, and you get like screens full of red, and you get grey hair as well, which before I started this project, I didn't have any. I work for a company called Lamp Bristol. We have long-term engagements with our clients. 4 of them we've been with for over a decade. And every single one of them, there has been major changes about their products, even things as fundamental as their pricing model and stuff like that. And these are often driven by changes that are way beyond technical changes. It's what the market expects, or it's just what competitors are doing, or maybe those initial assumptions we thought would work from a business perspective didn't. So change really is the only constant on all of those projects over the 10 years. And if at any point you think it sounds like I know what I'm talking about, it's only because I've made some terrible mistakes. That is, basically this is just an anthology of all the worst things I've done in coding, in the hope that, well, with regarding to testing anyway, in the hope that you won't make the same mistakes. So if we could have a test suite that was perfect, what would that test suite be like? First of all, it would run lightning fast. I'd just run tests, and within a second, I would see all of my results. And hopefully they'd all pass. But if they didn't, it would be easy to find out where the problems were. And the effort to create this test suite in terms of my time would also be minimal. And when I want to make changes or add things, it wouldn't cost too much of my time or indeed money to run them. So we want fast tests, we want low-cost tests, and we want high coverage. And by high coverage, I don't mean lines of code. I mean, if you could write down every single way in which somebody was going to interact with your system and the expected result, and you can make all of those things into a test, and you would run all of those, and they'd all pass, you would know that your code, your system would always work. Now, of course, the reality is we cannot have all 3. We probably can't really even have 1 or 2 of these. Because if we want high coverage, then probably it's going to cost a lot to build this test suite, and it probably is going to be slow to execute. If we want it super fast, we probably can't have the other 2. So everything in software development, and probably life even, is a compromise, and it's about understanding those compromises and applying those compromises, or having an understanding so you can appropriately apply those compromises to whatever project you're working on. So I'd also say if somebody tells you something as fact, this is the only way to do it, or this is the only way of doing it, they're almost definitely wrong. They might be right in the context they're operating in, but applying it globally is almost definitely wrong. So let's That's what we're aiming for. We're never going to get there, but we'll see what we can do to kind of get a bit closer to that. And again, this is based on my experiences, and your experiences are different, so not everything will necessarily be applicable. First thing I want to talk about is a concept like the testing continuum. People talk about things like unit tests and integration tests and end-to-end tests and system tests, and it probably all means something slightly different to different people. One thing we can probably all agree on, though, is the smallest thing you could test would be a single function that has no dependencies on anything else. It takes primitive values, it returns a primitive value, and it doesn't call anything outside of its function. That is probably the most atomic thing that we can test. So this is kind of at that end. And right at the other end, we have our entire system, and we are interacting with it as a user of that system would be, or if it's an API, as another bit of software would be. And all our tests, therefore, have to be somewhere along this line. So I do that so I don't really have to get into arguments about what is a unit test or what is an integration test or end-to-end test, because it probably doesn't really matter too much. So this is one end, and the other end is we're testing the entire system via whatever interface there is to that system. And if we think about some of the compromises, generally at this side, the tests are going to run fast because they don't have any external dependencies. They're not executing much code. Generally, at this end, it is low effort to write. Oh, sorry, and execution speed is normally quite a bit slower at the other end of it. And that would be because often, you're testing a lot more code, but also that code is probably talking to things that are external or things that are slow relatively, like databases or file systems or things like that. Generally, the effort to write a test increases as we go from here to there. Debugging clarity. If we're just testing a single function and a test fails, we know it's got to be somewhere in that function. If we have a test that fails and we're testing the whole code base, it could be anywhere within that code base. Realism. If we are testing things at the system level, that is much closer to a real user of the system, whatever that is, whether it's a person or a machine. And it's probably closer to whatever business requirements people have specified. If we're going down here, often it can get quite abstract. We're testing something, and to kind of get from that point back to the business requirement probably takes a few more steps. Ability to change. This is interesting. If we have tests of the whole system, what we could do is we could throw that whole system away and rewrite it in another language, and those tests would still be valid. So in some respects, testing at that level is great because we've completely decoupled ourselves from the intricacies of whatever system we're testing. But it also means if we do make test changes in here, then sometimes you've got to do a lot of, depending on how well and cleanly architected the system is, there might be knock-on effects throughout. If you're just changing the function of a single unit, often that can be quite easy to change, but that might have problems downstream. Coverage, again, this is a kind of an interesting one. At this level, it's very easy to say you have fully tested every single function if that's what you choose to do. But just because you have doesn't mean we've got any coverage in terms of business requirements at the end. And just because you're probably never going to get high levels of business. Well, you could get most of your business requirements you could write tests for, but in reality, there's so many combinations that you could have, like one line of business requirement could lead to almost infinite number of tests, depending on what it's trying to say, what it's trying to do. I also think that a test can be negative, as in it is cheaper to write a test than to do it any other way. And this is an example of something. So imagine we have a template parser that we want to parse. We give it a string. The string might have like placeholders in, and then you give it an array, and it kind of populates the placeholders with the data in the array. So we are just wanting to test the template parse method. If we were going to do this without tests, then we'd somehow have to execute the template parser parse method. Maybe we'd have a script and we'd type in values and we'd look at the output. Maybe we'd do some kind of debugging. But the benefit of a test harness, this is all the bit that I've covered in red. This is all the code we need, assuming we're using something like PHP unit, to provide a test harness for the template parser. And then these bits, these are the tests. So each test is just a line of code here. So we've got 4 tests there. And that essentially is a test. So once we set up the test harness, if I think of a new test that I want to do, I just write something like that. And this is almost definitely quicker than any other way of validating that the system works. And once we've written it, those tests are always there. So when I'm working on new functionality with the template parser, I know that I haven't broken any of the existing functionality. So that's why I think it's a good test, because that is cheaper to write the test than not writing the test. It is these kind of things where testing is at its most beneficial. And it's a good and it's easy to test because the template parser, from the level we're looking at, it probably doesn't have any external dependencies anywhere else. And there's this concept, I don't know how many people use PHP unit. Anyone use PHP unit? Yeah. Have you heard of data providers? I would say, so what happens in a data provider is you kind of have a standard test. You say, so then you can pass whatever number of parameters to the test, and then it actually gets the data to fill those in from the method name, in this case, happy path test, and then this returns an array, and that array kind of comes down into the template test. So I've only done the happy path test. There'll be a whole set of error tests that will come with this as well. But generally, if you're testing something and you could sensibly use a data provider, it probably means you've done something good with architecture. That might not always be true, but it's kind of an indicator. We could increase the readability slightly if we wanted to. We could put these things in here, so the keys, and then that, when you're reading it, I think it makes it even more obvious. We're expecting hello world. Our input data is hello, and then kind of angle brackets and 0, and we've got data and array with a single thing. So somebody looking at that, even if they're not a developer, well, maybe someone semi-technical could probably see what that is doing, even if they're not necessarily a developer. And if they are a developer, it's quite easy for them to see what they're doing. So I love this kind of stuff. If only we could write all of our tests like that. The reason we cannot write all of our tests like that is because often the software under test is talking to some other object that it is collaborating with. Software is too complicated to have lots of simple functions. They have to, if in order to do anything useful, it has to talk with something else. And when it does, we've got 2 options. The software under test, we can use the real thing that it interacts with, or we can replace the real thing with something called a test double. So to the object under test, the test double looks like the real thing, but it is not the real thing. And there's lots of types of doubles. And as we go from here to the other end, the coupling to the software under test is increasing, okay? So what do I mean by that? If we have something at minimal coupling, maybe we have our software under test and it needs something like a logger. And for this test, we don't care about logging. Our test isn't interested in the logger, but we still need to provide a logger to whatever we are testing. So we could do something like pass in a null logger or dummy logger, and we just don't care about that. It's not relevant to this. It just, the null logger looks like a real logger, but it just doesn't do anything. So there's no real coupling. I mean, okay, the dummy logger has to comply with the logger interface, but beyond that, it doesn't matter. Then we have a stub. So that means if your software under test is collaborating with another object, maybe another object has to return a value. and that value is relevant. So we could have something, maybe we have got a software under test and it's asking, is this user logged in? And for the purpose of that test, the user is logged in. So all we need is a stub that says, is it logged in? And it just returns true. So again, it just has to comply with the interface, and it's just always returning the same thing. Next, we have a spy, and a spy will do things like, suppose our software under test wanted to send an email. It might say send email, and our spy just collects all of the emails that would have been sent had we been connected to a real email sender. And then at the end, the test can say, how many emails did you send? Or did you send an email to this person with this subject? So there's more knowledge of the software under test. Then we have mocks. Mocks will record a lot more detail. They'll say, for example, you might say, expect a function call, and I expect it to be called with specifically these parameters or these arguments, and I'm going to respond in this way. You could go even more advanced with the mock, say, I expect this method to be called exactly twice, or 3 times, or none times. And then finally, you have a fake. So for example, if in a real application you are talking to the database via a repository, like a doctrine repository, your fake one might look like a doctrine repository, but it doesn't store it in a database. It tries and stores everything locally. So these are the types of doubles. And the problem is every time we use a double, we're not using the real thing. And if we think about the problem we'll have is because it's not the real thing, our model of what we are replacing might not be correct. And where there is not 100% parity between the actual collaborator and our mock, that is where issues can come in because our tests are based on something that might not be true. So there are times when we absolutely have to use a double. We can't use the real thing. We can't really make payments in our test. We can't really send emails in our tests. And we certainly can't talk to external APIs in our test. Even if they provide sandbox versions of those, if our test is running, say, on GitHub Actions and there is an issue with Stripe Sandbox, all our tests will fail. Okay? It's not really practical, even if we're not talking to the real thing, to use external APIs in that way in our testing. Then we've got a kind of it depends column. If we're talking to a database, we could talk to the real database, or we could talk to something that looks like a database. File systems, we could talk to the real file system, maybe not. If things are dependent on time, then we probably do want to provide a double because we can't use the real system clock because that changes. The same with random. And times we definitely don't want to use double. If we've got value objects or DTOs, I can't think of a time when we wouldn't want to use the real versions. You might might disagree. So how risky is your double? I think it's all to do with the interface width. So if it's narrow, if you've got one bit of the system talking to another bit of the system, and you have a very well-defined interface between those two. So for example, suppose you wanted to send an email. You have something that says send an email, and there is an email data transfer object, which has just got subject, who it's from, who it's to, and the message. Those 4 fields. There is no real scope for, as long as you pass something that's valid and has all of those fields popped in, then the thing that actually sends the email will take that and send the email, okay? So that is quite there's a high chance that your double will behave correctly. It will behave like the real thing. So it's probably relatively safe to use a double in that respect. But if we think about a database, there's a lot of behavior going on in a database. There's things like transaction boundaries, which maybe you haven't thought about. There's things like you might say, I want to persist this object, but this object has relationships to other objects. So you say in your dummy repository, you say, I save a new person, but when saving that new person, you've also created the company that person belongs to. Your double repository, your repository double has to be very clever, and it has to mimic exactly all of the information, all the things that a database would kind of give you out of the box. So that is a lot more risky. So perhaps if we can avoid using database doubles, that would be better. Does that kind of make sense? Yeah. Now, if we are going to have doubles, what we can do is write contract tests to check that the real thing and the double behave in the same way. So what we could do is, suppose we have a user repository. It's got a save method and a find by email method. And the find by email method takes an email and it returns the user if there is a user with that email address. What we could do is we could then create a user repository contract test, which is abstract. It's got one abstract method, which is create repository, and we're going to delegate that up to the concrete implementation. Then in our test, we call create repository. We are going to add a new user with alice@email.com. Note the capitalization of A and E in the email. And then we're going to save that in repository, and then we do find by email, but we're finding the lowercase version of alice@example.com, and we're asserting that the user has been found. So then we would provide two implementations, a MySQL one, this is the real version, and our in-memory user repository. And that basically gives us two tests, one with the MySQL one and one with the in-memory one. And what we might find is our in-memory one, we'd forgotten that. So in MySQL world, generally it's case insensitive. You ask to search for something and it won't care about the case sensitive out of the box. But our in-memory user one, our kind of replication of that, we might have made a mistake where we were looking for the email exactly, not in a case insensitive way. So these tests are there to help protect against that and checking that the behavior we want in the real one is the same as the behavior in the double. Of course, the problem with that is you've got to know enough about the behavior of the real system to know you've got to write a test for the double. But let's imagine that our in-memory one didn't account for the fact that usernames could be, emails are case insensitive. We could easily develop a system where we have duplicate emails in, even though we're not supposed to have them. And then the real system would crash because it would say, get me somebody with this email address expecting it to be unique, or try and create someone with this email address expecting it to be unique. And because our test version of it didn't behave like the real version, we let a bug get through that could have been caught in tests. So the real question we should be asking, I think, is can we avoid the complexity of test doubles altogether? Because if we can, there will be a couple of benefits. One, our tests will probably run faster. And remember, fast execution speed is one of the things we are after. And our tests will probably be lower to maintain because we're not having to worry about creating these doubles, or we're not. Yeah, basically, the maintenance will be lower as well. So one thing we could do is potentially re-architect code. So this is a real mistake that I made. We have some code that does invoice generation, and we have essentially this method called generate invoices. And what it does is you say, generate the invoices for February 2026. It will get all of the customers using customer repository. It will then iterate through all of those customers, and it will go off to a services repository to see what services that customer had. This is now in an inner loop. So then it looks up the prices for all the services. It looks up if there are any discounts for all the services. Then it calculates the prices, which is essentially where all of the clever business logic is. Then it generates an invoice object. It passes that to go and turn that into a PDF, and then the PDF is emailed. And because this is all in an inner loop, we've got all of these things that in red that we either need to provide test doubles for, or we use the real version. And we certainly don't want to be sending emails. The PDF generation is quite slow, so if we had hundreds of tests, because we're testing lots of different bits about the calculate pricing thing, our test would run very slow. We potentially have to have a lot more set up to get the database in the right state for all of these tests. So from a software perspective, it looked a bit like this. The invoice calculator had 7 dependencies, and it's going through doing all its difficult things. So we do care that everything is wired together, but we care also about the complicated calculations that we needed to do to generate the prices. So what we could do is we could re-architect our code. We could split it into 3 bits. Our first bit is to gather all the information. So what this would do is it would go to the customer repository and get all of the customers that needed to be invoiced in March 2026. Then we could iterate through those customers to grab all of the services that they've got. And then we can go and grab all the prices for those services and all of the discounts. Now, whether you can really do this probably depends on the numbers that you're pulling into memory, but it's a question you should ask. Because here, there's not really that much data we're pulling into memory, especially on servers these days. So we have this first bit which gathers all the information, and then it passes it off to the generate prices function. And the generate prices function is, it just takes some input and works out the output, and it will produce a set of invoice objects. And then the process information will put the invoice objects that the generate prices has made, put it into the invoice repository, and it will also go off and do the PDF generation and the emailer service. So the benefit of this is the bit that will need lots and lots of testing is this bit here. This is where all of the complicated logic is, and we've essentially made it a pure function. We give it input, we expect the output. And if I'd done that on this project, it would have made testing all of it a lot easier. Because essentially our price calculator looks a bit like this. We're just passing in the information that we gathered, and we expect an array of invoice objects at the end. It's much easier to test. It's almost going to be as easy to test as that first example I showed you. The setup will be a bit more complicated, but and we could probably do it using, well, it'd be very simple to do, relatively. It'd be a lot simpler than what we do now. And of course, our generate prices code could have dependencies on other things like discount logic 1 and discount logic 2 and maybe other things related to pricing. And as long as all of these things in yellow don't really have any dependencies apart from, in the case of generate prices, it has dependencies on things that are essentially also pure functions when you look at it, that's okay. Okay? Are we happy with that? So the number one thing we should be thinking about when we're writing code, if we have areas of complexity where to safely deploy that code, we know we need a lot of tests. Can we re-architect it in such a way we pull out all the data we need, we do whatever processing we need to do, and then we do something with that data that it's kind of the logic that it has applied it to. This has got some benefits. It's moving a lot of tests that were maybe a bit further along our test continuum, essentially to the properties of down here. They're going to be pretty quick because none of this stuff in the yellow is talking to any kind of databases or anything like that. It's just code. It is also, when you take it in its more complete form, probably closer to the business requirements. You know, you'll have a business requirement that says, given this, I would expect a discount to be, the customer to be credited with a discount. So it can help with cost. It also makes our test suite lower cost to create in the first place because we don't have the complexity of putting databases in certain states to do lots of complicated tests. So this is really helping us, this kind of re-architecture is really helping us in terms of making a better test suite. We still do need to test that all these things are wired up correctly, but that is something we'll talk about in a bit. So the next thing we want to do is we've kind of got two types of code, really. We've got things in the yellow boxes, which is just, it's kind of pure business logic, really. And what we're aiming for is to have as many of these collaborating with each other as possible. So if we think about our test continuum, we want to push it as far along there as we possibly can, because these are fast to run and much cheaper tests to create. And in terms of how we test this, we could test all the individual boxes on here, but also these bits will eventually talk to blue bits, and blue bits are kind of that get the data in and get the data out and collaborate with other parts of the system. But essentially what we're really asking ourselves is, if we just use this generate prices as the interface to the code that we want to test, it doesn't really matter if we're testing at the generate price level, or we also have additional tests for discount logic 1 and discount logic 2 and generate prices. It's whatever really makes sense. Of course, if we did have tests for discount 1 and discount 2, one of the tests we would then need on generate prices is that we have correctly talking to the discount 1 and discount 2. So we're asking ourselves, does this work? Does this yellow box work? It's pure logic. There's lots of tests. And then hopefully we can get a lot of these things collaborating together, and they're still super fast, and there will be lots of these tests relative to all the other tests. And then the other question we need to ask is, have we wired all of this up together? So we definitely need to do this test. Just because all the yellow bits work doesn't mean the system works, because until we answer the question, have we wired the blue and the red boxes up correctly with the yellow boxes, we can't be sure that everything really is working. So what we're really asking when we've got the blue boxes is, it's not, are we doing the right thing? It's, have we connected everything together correctly? So for example, suppose there were 10 different things we could test about discounts. We would need all of those things tested with the yellow boxes. But when we add in the blue boxes, we've really got two tests. We've said, if we don't have any discount, does it work? And if we have one discount, does it work? What we certainly don't want to be doing at this level is repeating lots of the tests from the discount level, because these are a lot harder to set up and they're a lot slower to run. So, and when we pick what tests we want to ask the question, are they connected together? We want to think about the things that are least likely to change. And that is sometimes quite hard to do, but we don't want to pick some obscure discount thing that might only be there for a few months and then sometime later it goes away. So, if, for example, at the time we were writing all this code, there was a special Christmas discount, that would probably be a bad choice to use for the use case to say, is the discount stuff correctly wired up? Because there's a good chance that Christmas logic will get thrown away come January. And there'll be far fewer of these tests. So down here we might have hundreds. Here we want the minimum we can get away with. And you might say, well, how on earth, if we've got lots and lots of tests, especially if we're increasing the test space of all of our kind of our pure logic, if you like, how do we know that we are not going to have duplicated tests? And there is this really neat thing we can do on PHP unit, and I'm sure you can do it on other testing frameworks as well. It's got this ticket attribute. So suppose we're working on a feature, let's call it feature 006. All of the tests specific to that, whether they are kind of down here or anywhere along there, we can add that attribute onto it. And that means we can then ask PHP unit that we can do the -- group and then give it the name of the ticket, and then -- list tests, and it will show you all of the tests that have this attribute on. So what that means is you have to get a recent version of PHP unit. This functionality has already existed, but the combination of these working together has only been fixed since about PHP 10 or 11. So then when you're working on a feature, you would make sure that all of the tests have got a ticket on them. And it is possible for some tests to have multiple tickets, which I think further down that way, they're more likely to have multiple tickets. And then just before you commit it, you can look at all of the tests and you can say, oh, actually, I see that when I'm asking if everything's connected together, I've got quite a few duplicated tests and I don't really need them, so we can get rid of the excess ones. So this is a really good way of managing the complexity of spreading our testing throughout the testing continuum. And incidentally, if you just want to run the tests for feature 006, you just do PHP unit group feature 006, and it will just go and run all of those. So the layered approach with the pure functions that we're trying to group together helps us get faster tests. It lowers the cost of the test suite because we are not having lots of our testing requiring difficult setup. And certainly if we can push our kind of pure stuff along here, it's much closer to the business requirements. And there's a project I've worked on where I have a lot of tests that really would have benefited from this kind of approach because I hadn't split things up. So I have tests that the test suite takes half an hour because I'm doing tests along there that a lot of it could be done down here. And there is an aside on this. If only I had, for every single feature I created, I'd put a specs folder in my GitHub repo, and I just labeled them however you're labeling your features. And then you just have a little bit of the markdown that just says this is what it's trying to do. And the reason for that is over the lifespan of all the projects that I've been working on for over a decade, we have moved from ticketing systems. So there's been things that have been in Google Docs, and we don't use Google Docs anymore. We have things in Trello, and some projects we've gone from Trello to ClickUp. And then there's Jira. And the point is we've got features from 10 years ago and we can't find the documentation for it. And if I'd just done something like that, my life would be much easier. Can anyone imagine working on a project that's undocumented? How terrible that would be. And yet we probably are working on that to some degree. There is also, I mean, this is a bit of an aside for what I'm talking about, but what happens when an unrelated test fails? So suppose I had feature 006 and it's all kind of documented there, and then I'm working on another feature, feature 1007, and I'm creating new stuff, and feature 1007 causes a test, which was feature 006, which had the feature 006 ticket on, to fail. I can then go back to this document here and go, right, what I'm doing now seems to collide with what we used to do. And that is a great time to then involve the people in the business to say, well, we can't implement this feature without breaking that old feature. And on a lot of projects, long-running projects, that's the kind of thing that happens, because when people are working on new features, there's so much intricate details from ideas ages ago that people have forgotten about. So this is why, and it's not bad that this happens, but it's really useful to happen, and it's really useful to say, this is what we were thinking 8 years ago, and that's why there's a clash with what we're doing now. And you just kind of go back and work out what the solution is. And the solution might be, well, we've got to go and change the functionality there. But that's fine, because now we've just got it's much easier to track where that decisions were originally done. And if you're using things like architectural decision records, then maybe just check those into Git repo and just use the ADR number for your ticket. You don't have to do this, but it's just to do something like that. It probably would also happen with help with onboarding, like if people are new to the projects and they go and find a test, they can then easily go from the test back to the specification or back to a version of the specification. And just imagine if you had all that information when you're adding AI to your projects, because now AI is so clever It would look at the test, it could look at the ticket. You would basically, you could tell AI, say, look, when you see this test, this is the thing in the ticket, there'll be something in the specs folder that matches that, and it can go back and look at it and get the context it needs when it needs it. So it would be super useful for AI to understand code bases, and it could be used as reviewing as well. You could have an AI agent that you say your skill is to look at any of the tests that have changed and then go back and look at the relevant spec and just say, are these two things in step with each other? And you would say, and it could say, it could alert us to the fact that this test has changed, but the spec hasn't, or it's changed in a way that it does not like meet the spec. And I think that is also quite useful. And in the world of AI-generated code, where we're churning out so much code so quickly, if we could tell the AI to annotate the tests with whatever it's working on, it makes it much easier for us as reviewers. We can just look at the tests and look at the spec. We can easily find all the tests and check that it is aligned with what we asked the AI to do. So another thing I want to talk about is decoupling our tests from the software under test. All of these tips will reduce the cost of developing the test suite and maintaining the test suite. And this is probably where a lot of subtle errors are made that people don't realize. So I think the golden rule is your test should only change if the behavior they are testing changes. There is an asterisk there. If, for example, you rename something in that kind of refactor, if you rename things or move something, then clearly the tests that reference that will also have to be updated. But those kind of rename and moving refactors, that's not what I'm talking about here. Those are kind of safe changes. Do them in a separate commit to anything else. Now, what you'll probably find is the further you go down here, the greater the chance is that you will have some issues with coupling. I'm going to take that slide out when I do it. This is my first run of this, and that slide's not in the right place. Sorry. Right. Okay, this is a big problem, is test setup. Again, this really happened to me. We had this concept of a company, and initially people just logged in. There was a generic login page. And then we decided we were going to give every company its own subdomain. So you couldn't log in from the main page. You would have your branded page, which would be on your own subdomain. So when we created companies, as well as like the name and their website and any other bits of their information, we also required a subdomain to be provided. And of course, the problem is, if we had a test, and these would normally be in the setup part of the test, that says company equals new company, and we pass in the details, suddenly that test will break because we're not creating company with a subdomain. So if you've got hundreds of tests that all create a company in this way, and then you add a new property or a parameter to the constructor, then all of those tests are going to fail. And it's okay for the test to fail that's specifically testing the new subdomain functionality, because that is new behavior. But there'll be tests that have got nothing to do with subdomains that will suddenly fail. And another thing that's quite common is you get people you get projects where they'll go through a YAML file or a CSV file, and then they'll kind of put that data straight into the database. And again, if the subdomain field was a mandatory field, then suddenly all of this would break, and you'd have to go back to your seeding data and add in this subdomain field. And this is problematic. It's problematic because if this is a core thing that a lot of your tests hit, then suddenly you're going to get hundreds of failing tests. So there are patterns to work around this. One of them is called the object mother. It's essentially a factory, and generally this would be used in cases where if they were users, you might name the users as, like, if you're using user stories where you have personas, then maybe you would name the users in the same way as your personas in the user stories. In this example, I've got company, so you probably wouldn't label them company 1 and company 2. You'd probably have something that was more relevant to whatever problem you're trying to solve. But you have an object mother, company 1, it would see if the company's already been created previously, and if it hadn't, it would create it. Otherwise, and it would create it, and then it would return the new company that you've just created. And of course, if something came along where you needed to add in the subdomain, it's just this one place that you need to change it. So all of the tests that required company 1 will work once you fix the company object mother. And another thing is the builder pattern. So you could do new company builder build, and this will just build a company with sensible defaults. And if you want, you can override each of these properties with something. And then what would happen is you would have, in the case when you've got a new property come along, you've just got the subdomain there in this kind of fluent builder pattern. And what that means is all of your tests that just required a company and they didn't care about the subdomain, that would all be handled by the company builder, because if you don't provide a subdomain, it will just come up with something sensible. And it just means that your tests will be a lot less fragile. And generally, object mothers and builders will potentially also defer to other object mothers or builders. So for example, if you had a user and a user required a company, then it could make use of the company object mother. And again, if you suddenly added in a new requirement, it's just all encapsulated in here. So when you're making a change, you say, I'm going to make a change to the code. I'm going to make a change to the code that creates the objects for tests, and all of the tests will continue to work. Everything changes. So this is another real mistake that I made. I had a project, and what would happen is you'd sign up to play these games, and 12 years ago, 13 years ago, everyone used SMS. And what happened is they said an SMS is a terrible way of communicating, especially conversational things. It's very difficult. WhatsApp is much better. So what happened is they came along and said, we want to add WhatsApp. But not everyone would go onto WhatsApp. So what would happen is you would register for a game, and the first thing that would happen is you would say, do you want to use WhatsApp or SMS? However, all of my tests, I was kind of using a pattern similar to the builder pattern, but there's probably about 500 of these tests that start like that. And then about 450, they immediately want to start the game. So I have a line of code that says player, send the start message. And there's 50 that don't need the game to be started. The problem is, this bit where you send start no longer worked when we wanted to add in the SMS or WhatsApp thing, because the first thing you had to do was reply with either SMS or WhatsApp. So start wouldn't do anything. So you'd come along, it'd run this test, it would set up a new game, it would then send start, and what the actual system would do is that, no, you can't say start, you've got to tell me if you want SMS or WhatsApp. So all 500 of our tests failed. I couldn't really change the functionality of the builder because some of the tests did want the game left in the start state, whereas others didn't because of what they wanted to do. So it basically meant I spent a couple of days going through changing 500 tests for no reason at all. You know, the behavior of those 500 tests had not changed, yet I had to go and change them. And of course, what I should have done is I should have just added to the builder a start game thing, and the games that needed to start, I would have called start game, and then when it built the game, it would have put it in start mode, and the others that didn't need it wouldn't. And then the fact that I've changed something about the start process didn't matter. So the real lesson is, if you do your tests like given, when, then, or arrange, act, assert, in the given bit, the only things you should be, anything that is not relevant, if you're just doing it to get it into a certain state, that, like in this case, a started game, it should essentially be one line of code. Okay, I know I put that over 4 lines, but it is one line of code. And the only other things that should be going in given are specific to what you're actually testing. Because if you don't do that, one day something will come along and cause you a world of pain. If only I had done that. And actually, generally, this kind of stuff I found is more kind of down there on the testing, more towards the system level. I would also say that when we're writing code, and I think, again, in this new world of AI we're entering, we want our tests to be like expressive, but I'm not sure if it's really worth creating your own domain-specific language. So some people might use things like Gherkin or Cucumber. There's a lot of effort in there, and I don't really know if it's worth it, to be honest. Like, how many people really give someone who isn't technical the access to write all their Gherkin tests? It sounds great, but honestly, I don't believe it really works. I'm often wrong, though. But if we've got something like here, you can read this. You don't know much about this project, but you can kind of have a good idea what's going on here, I think, hopefully. And it's really important in the same way that when we set things up, our assertions are encapsulated as well. So if something changes about how we receive messages, we just need to go and change the assert methods, and all the tests will still continue to work. So I think this is kind of our best compromise. We don't want tests which are so complicated to understand we can't understand what's going on. So I think it's good if they read like something, almost like English, but I think the effort to get it to English with all the intricacies you need in the real world is probably a step too far. So I think something like this is a nice, a relatively good compromise. And the send message thing, that's another example of something that completely changed when we introduced WhatsApp. But because, fortunately, I had encapsulated that correctly, it didn't break too much. I just had to go in and update the send message. And the same for many of the assertions. Over project was released in 2011. So over 15 years, a lot of the behind the scenes bits of this have actually changed, but the tests haven't had to. So if we can decouple our tests from our software under tests, this will greatly reduce the cost, more the ongoing cost of our test suite. It will allow us to make changes, introduce new functionality without breaking any of the original things. And that section is probably the bit that you've probably got your biggest bang for your buck in terms of like small little changes you can make going forward. So in summary, we're aiming for fast tests that do not cost much to maintain or build, and they have a high level of coverage. If we can architect a lot of our code into what I'm calling pure functions, they might not technically be pure functions, but functions without any dependencies on external things like databases or anything where you've got to really make complicated doubles for. If you can architect it that way and you can group a lot of that stuff together, that means you're going to have pretty fast tests with high levels of coverage. You've got to be really careful about your use of test doubles. If we can avoid them, that's probably good. Not everyone will agree with that. But there are some times we absolutely have to use them. The layered approach and careful checking that we're not duplicating the same kind of test at several levels throughout the test continuum is essential as well. And do think about when we are writing tests, we are decoupling our test code from what we are testing. Those are my takeaways. I have been Dave Liddament. Thank you for listening. Any questions?
Any questions over there?
Yes.
You need to speak in the little thing.
Oh.
Hey, I was interested because where you were showing the PHP unit attribute, the ticket attribute, is that like a... I've used group before. Are they like sort of synonymous? Is it like an alias?
Same. Well, no, they're not the same. If you know the minus group,
yes,
that will look for either groups or tickets.
Okay.
So I would say, well, it doesn't really matter how you use them as long as you're consistent. But
Right.
I would personally, if I was going to add groups into things, when I was talking about the yellow and the blues and things like that,
Yeah.
I would have all of the tests that were essentially just testing one class, or that had zero dependencies elsewhere. Might put them as, I'd have those as one group, and that group you would want to run first if I was going to use groups. Then the next group of things would be where you've got multiple yellow blocks collaborating together, and you want to run those second because you want to make sure that the things that are built off had passed before you move on to the second ones. And then when you get to the blue ones, maybe you'd call them integration or something, but you wouldn't want to run those until you'd run all the yellow ones, if you see what I mean. Because you want to have everything built here before you kind of use the things that are built from it.
Yes.
Does that make sense?
Yeah, makes sense. Makes sense.
So that would be the context in which I would probably think about using group. But then there's no rules on that. You could group whole. I suppose if you if you had a modular monolith, for example, you could use group to move things along there. But if it was a modular monolith, I'd probably filter on other things. I'd probably have test suites for each bit of the modular monolith. So, there's lots of ways of skinning the cat, if you see what I mean.
I see. So I guess it's just like they both work with the group. You can filter them by using the group parameter, but I guess you could say ticket could be a Git issue number, maybe. Is that
it could be a Git issue number. It could be the feature you're working on, however you do that. I think, you could definitely do the Git issue thing as well. Or, it could be both. It could be, if the Git ones could start Git, then the Git issue number, and then the requirement ones or the feature ones could start requirement or feature, and then a number. It can be whatever you want it to be, really.
Yeah.
But whatever system you want to use, just make sure everyone uses the same system.
Thank you. Yep.
Yeah, I gotta say I wasn't aware of this feature either. It's quite interesting. Any other question?
Okay.
Well, I've got one. Tests have been around for a while, right? And I think pretty much to every conference you go to, there is a talk about tests. It's like it's very present. Like people know about it, and yet there's still a lot of developers and companies really that still don't use tests at all, right? Why do you think that is?
Why don't people use tests? I think there's a couple of things. One is training. And part of the problem is if you've never written a test before, but you've written code, and then you come in and you start doing a lot of the normal training and testing, which you have to do. You have to kind of start with doing like the really basic code katas, And what you're doing in that is just miles away from what happens in a real code base. And what happens, I think, is people just get impatient. They think, right, I've learned how to do, I would say if you've never written any tests, and start with all of these TDD kind of testings, even if you don't end up using it in your actual code in that way. But you need to understand those things, like how to write a test, given, when, then, act, arrange, assert, or arrange, act, assert, those kind of concepts. And you need to practice them on things which are probably way more basic than what's happening in your real code. And then I think from that, and then getting to what happens in a real code base, people just give up and they go, I haven't got time to do this. I've just got to get this feature out. And then they just give up. And the problem with that is it then snowballs the problem, because often if you haven't written your code with testing in mind, it often turns out hard to test. So then you get into a situation where the code is actually quite difficult to test. And the time you would need and the experience you'd need to be actually able to write tests for it is quite high. And then people go, is it really worth it? It kind of works. But so I think these are the kind of reasons that happens. People try and rush stuff at the start, then you get into a situation it's hard to test, and then the people that training people do. It's a bit like somebody goes, oh, I'm going to do, I've never run a marathon, right? I'm not going to do couch to 5K. And they go, why can't I run a marathon? It's because, well, the couch to 5K is the start bit. And then you've still got another 3 to 6 months before you can run a marathon, right? And they just want to be able to go, I want to run a marathon. Or that's what I'm required. I think this is it. And these kind of, the architecture isn't right for testing. And the fact people don't invest the time to get to a level where you need to be
Makes sense,
to do that is the problem. But really, if you start from testing from the start, I mean, I think the main benefit of something like test-driven development is your code will almost definitely be able to be tested because there's no other way of doing it. Yeah.
That makes sense. And actually, I've got a related question. So in your experience, optimizing for tests, does that always lead to better architecture? Or is there like a risk that you might kind of corrupt your architecture because you're trying to, for the sake of the test, essentially?
I think on the whole, if you make code that's set up well for testing, it is a good architecture. There are definitely times when I've done things for the sake of testing, and I can't think of an example off the top of my head where I thought...
Public methods, for instance. Public methods just so they can be tested. I see that all the time.
Okay, so public methods so they can just be tested. If you use static analysis, I have written a PHP Stan extension for that. And what you can do is you can put the test tag attributes on a public method, and PHP Stan will make sure that you only call that method from test code. So an example where that would be, a case where that might be, is if you have an entity which is persisted in the database and the database allocates the ID of the entity, but you are writing a test which requires that field to be set, then you have to somehow expose access to that ID method, so that ID property. So the easiest way of doing it is to have a set ID method, but you want to make sure that is never called by application code, only by test code. However, taking a step back, these days you probably shouldn't be allowing the database to assign the ID property. You should use a database viewer type thing. However, any code that's written for over like 5-10 years ago, it will be using the database's primary key to allocate the ID. So, but that is the kind of example. And actually, I think on that point, sometimes you have a class that, in order to test an element of it easily, you split it into two. So then you have two classes that are very tightly coupled to each other, and really, if you didn't care about the testing, should be one. And there's a couple of solutions that you could put like a public method on that kind of accesses some of the internals to either set it or to get data from, and then you could use a test tag. The other thing you could do is often when you've got lots of classes that are collaborating together, they'd be in the same namespace, and one of them would be in effect public to the rest of the code base, and the others should be just only used by other code within that same namespace. And the same label, it's the same, and actually a lot of languages have that concept of, like, Java has package and other languages have namespace. So, you've got public, private, protected. You've also, some libraries, some languages have package or equivalent or namespace. And that same PHP Stan library, you can just put the namespace attributes on the class or the method, and it means it can only be called by things within the same namespace. So if you find yourself taking a class, really, if you weren't testing it, would be one thing, but putting it into two, you can do the thing that should be internal. You just give it the namespace attributes, and it will only be everything in that namespace and call it. But yeah, no, those are the kind of cases. Yeah.
Excellent, thank you. Yeah, I know you did a lot of work around attributes, and I really need to check out what you've been doing.
I mean, it doesn't matter now. AI is doing all. So.
Well,
none of this matters anymore. Yeah.
Another question over there, yeah.
Yeah, I was. So talking about the kind of continuum, I tend to use, like, right over at the right hand side, the kind of browser automation tests, right? I tend to use those as almost like the last resort because they're so kind of expensive in terms of developer time to write and debug and run. They're really slow and they break. They're really brittle, you know. So I guess my question is, do you have any sort of heuristic, like a rule of thumb, where you kind of go, okay, well, this now I'm going to do a browser automation test rather than testing with, you know, feature integration or, you know, unit test right at the other end? I guess you'd be talking really the middle tests, right? Because I always try to do as much with those before I get to browser automation. Yeah. But I don't know that I have like a little rule in my head when I go, that's the right time to do it.
So the whole, I might add a slide about this, thank you. The whole thing about controllers returning, like every framework, and it's not just PHP, every single framework, your controller, you know, you do this render or do something like that, and essentially it's returning a string, or it might be a JSON, it might be a response object, but the response object is the, you know, if it's HTML, it contains like essentially the raw HTML in it. Yeah. You know, and from a just testing thing, why do you not, like, why would you ever do that? You know, like before, 10 years ago, you would return a template. Well, no, you'd render, say, this is the template and this is the data I want you to put in the template. And it always bugged me that every single MVC framework, instead of returning like a response or a string, it should return an object which says, this is the template, this is the data, and these are the headers. And then when you're testing, you would just do the testing at that level. And then essentially does that make sense? So
I mean, Laravel has that. So you can do that with Laravel responses. Right, yeah. So I tend to lean on that a lot.
Yeah. And then
so it's interesting.
And then you're just testing essentially, it's like testing an API. It's easy as that.
Yeah.
But what I would say is a lot of people in their views, I think, put too much logic in their views. So for example, what I'd probably do is, sometimes people return like a model in their reviews. I think that's a terrible idea. I think what you should have is something called view models, and a view model can only be made of primitive types or other view models. So by default, everything will be a primitive type in what you return back, with the exception of forms, but like stuff you want to display. And if you do that, right, and then if you have got to decide, am I showing something or hiding something? Like if, for example, you're showing a table, but if there's no rows in the table, it would show something else. Or you've got one div that you show if it says there is no entries, click this button to add an entry, or the other thing that shows you all the tables. I would actually have in my view model like a Boolean thing that says you're showing this, yes or no, your Boolean thing is showing that. And then your test can be, you would never actually fire up a browser to look at it, but you would be saying, is this Boolean true? Would I see the thing, the table, true, false, or would I see the thing that says, there are no entries? And that would be the level of the information I'd have in the view models. So you'd never put in actual real models, you do it at that level. And then your tests are really easy to write. You've got a very good idea that what you're telling the view to display will be correct. Now, of course, somebody could get that wrong. They could transpose those two things in the actual view logic. But if you think about I was talking about the interface width, it gets a lot thinner if the data in the view models, which that's what you're doing all your testing on, is everything's flags, or everything's kind of data. Does that make sense?
Yeah, absolutely. Yeah.
And I think that's that makes it easy. And then you've still got to then check if you've actually wired everything up correctly, but that probably could be a manual check. And you could probably even go and be a bit more clever than that, in that if anything in your view model changes, which you see is used in whatever template, twig or blade or whatever, you could probably have a bit of tooling around that says you actually need to look at this, specifically this bit. And then it's not something that has to be done every time. It's just the times when it needs to be done.
Yeah.
Have I expressed that well enough?
Yeah, thank you.
Okay, good question. Like it, yeah.
Any last question?
Yeah.
Anybody? No? All right, let's get another round of applause for Dave.
Thank you very much.